5.1 perpendiculars and bisectors. I'm going to start this one out with looking at GeoGebra, and we're going to look at the first theorem of the section, perpendicular bisector theorem, and consequently its converse. But basically, if I have a segment and I bisect the segment, remember bisect means divides it into two equal parts, so you can see AC is 3.61 right now and CB is 3.61. It bisected it, they're equal parts. And it's also perpendicular, a line perpendicular through that point of bisection makes this a perpendicular bisector, this thin black line right here. And when we have a segment that has been perpendicular bisector, our first theorem today says that any point on that perpendicular bisector is going to be the same distance from the endpoints. Another word for same distance is equidistant. So D is equidistant from the endpoints. Now, the converse to this theorem, perpendicular bisector theorem, that's theorem 5.2, says if D is equidistant from the endpoints, then it's on the perpendicular bisector. So notice these lengths always stay the same. I can change this segment, move it around. I designed it so that it's still a perpendicular bisector, still have a right angle, same lengths. And if I move D, that length is always going to be the same. Okay, I can even bring it to the other side of the line here. Those lengths are the same. That's our first theorem, and we'll look at that now. Basically what I've been saying, CP is the perpendicular bisector of segment AB, and CA is equal to CB, where the converse basically says if CA and CB are equal, and then C is on the perpendicular bisector. It doesn't say CP is the perpendicular bisector, but it says it is on it. The next theorem, I got another, it's going to be the angle bisector theorem. And this angle, I don't have it measured, I guess, but this angle and this angle are congruent. It divides this ray divided it into two congruent pieces. So if I move point D in or move it out, and I can change this angle. Okay, what do you notice about these two segments? They're always the same length. Now, could be a silly question, but what if I put a different segment here, like this? Is this segment and this segment going to have the same length? Okay, we know when it's here, it has the same length as that segment, segment FD, but does this segment have the same length? Well, it's not just, it has to have a right angle here. Okay, when you measure the distance between a line and a point, you measure that distance at a right angle. So this segment and this segment wouldn't have the same length. It only would have the same length if it is a right angle. Okay, that's important to pay attention to. Now the converse says if this is a perpendicular line to this line and it's the same length as the perpendicular line to this line, then D will be on the angle bisector of that angle. Okay, so they're kind of complicated theorems. I have these GeoGebra things on the Moodle site so you can play around with them and experience this for yourself. But those are the four theorems all in total, the two theorems and basically their converses. And you see that BD is congruent to BC, but make sure you measure it at a right angle. It has to be, that's how you find the distance from a point to a line. It's got to be a perpendicular segment. Okay, once again, that term equidistant. Equidistant means same distance. That's important to remember. that new vocabulary word. And one example here, if MN is a perpendicular bisector of segment ST, what segment lengths in the diagram are equal? Well, if MN is a perpendicular bisector, and we're assuming that point M is on that perpendicular bisector, therefore this segment has to be congruent to that segment. That's that first theorem. Now, also, what do we notice about Q? Notice since Q is equidistant, the same distance from S as to T, since it's the same distance, Q has to be on the perpendicular bisector. And since MN is the perpendicular bisector, Q is on MN. Okay, yes. And you notice my handwriting is a little sloppy today. I'm not actually doing this with a mouse. Those are the same, so that one's yes. And since MN is a perpendicular bisector, we know these are true. That's where I got that from. Here's what I got for your homework. Have a good night.